Okay. With this one, and the good news is the quiz, I promise, is short. Won't take you too long, I think. Let's hope. All right. It says here, determine the minimum force necessary to move block A. Question for you. Can you tell me the different cases in which A moves? Obviously, A could slide out on its own, but what else could happen? A and B could slide out together. So you have to watch for these things. There's two cases here. There's case 1 where A just slides out on its own. And then there's case 2 where A and B slide out together. Do you know which one it is? Not really. Okay? So you don't really know which one happens here. Okay? So what do you have to do? Any guesses? Analyze them both separately. Yeah. So let's try the simplest, I think, for everybody to look at is the case 1, which is A slides out on its own. Okay? Now, recognize here, be careful, each one of these blocks has a different weight to it. Okay, notice the thing here. It says WA is 20 pounds, WB is 40 pounds, WC is 60 pounds. Okay, everybody see that? Okay. So we need to first analyze the case of A sliding out on its own. Okay? Let's draw a free body diagram for this block at A. Okay. So, start with the easy part. This is force P, pulling to the right. Okay? And then you've got, this thing weighs, okay, I'll just kind of label this here, make sure you understand. This bottom one's the lightest. It weighs 20 pounds. Okay? So obviously there's a weight force down of 20 pounds. Okay? Obviously, the ground pushes up. I'm going to call this ND, normal force at D, pushing up. Okay? And what else is going on? C and B are pushing down. Okay, now, be careful here. I'm going to call this one NBC, like that, because you might think, well, hold on, the weight of B is 40 pounds, and the weight of C is 60 pounds. Isn't that just 100 pounds pushing down? Why is that not true? Why is it not true? Because maybe you're wondering the same thing. Why don't I just write 100 pounds down there? Why do I write a normal force? It's 100 pounds on top of it, right? Yeah, the rope. Don't forget the rope. The rope's doing something, okay? So that rope might mess things up. So if I'm not sure, I'm not going to put 100 there. I'm not going to put 100 there because, you know, that rope may be doing something too. So I think I'm just going to write that as NBC, as a normal force from BC down. Okay. Now, in this case, A slides out on its own. A is sliding relative to D, but it's also, do you see this? It's sliding relative to B as well. See that? So everybody probably sees this and says, oh yeah, there's a friction force, and I'm going to call it FD, right? It's like that. But don't you also see there's a friction force on top? I'm going to call it FB. see both those? Okay. So this is getting complicated. You got two different frictions. You got all sorts of stuff. Now, if A slides on its own, is it safe to assume that both FD and FB are at their maximum frictions? Yeah, right? Because it slides out. So I've got a couple more equations too. I can then safely say FB is equal to the friction coefficient between B and A is 0.3. You can see it in your picture. FB is 0.3 times NBC, and FD, it's FD. FD is equal to 0.2 times ND. So that gives me a couple more equations here. Okay. Now, help me write this equation. This should be pretty easy. Some forces x equals 0. Let's say right is equal to positive. That's going to be P, and what else is there going to be in the x direction? Yeah, minus FB minus FD equals 0. That's easy. Okay? And let's write the other one here. I'm going to write it over here. Some forces in the y direction equals 0. Up being positive. What do we got in the y direction? That's pretty easy, right? What's in the y? ND is up, right? What's down? The 20 and the NBC. So it's minus 20 minus NBC equals 0. Now I got 4 equations. Can I solve this? How many unknowns do I have? Can I solve? How many unknowns? Let's count them. Let me write them all down. I don't know P. I don't know FB. I don't know FD. I don't know ND. And I don't know NBC. Oh, shoot. If I would have just assumed that was 100 pounds on top, I would be able to solve this. But you know what? If you assume it's 100 pounds, you get the wrong answer. Yeah. That's one of the 4 equations, right? I've boxed in blue all 4 equations. So yeah, you're right. But then you could say it's unknown, but you eliminate an equation. Yeah. So do you think I can solve this, or do you think I need to move on? Or you're not sure? Do some moments. Can you do any moments here? How do you do moments? Look at that picture. How do you do moments? What's missing for moments? Distances, dimensions, all sorts of stuff. Yeah, I don't have any moments here. So I can't solve this. What do? Give up? Throw my hands in the air? Draw something else. What else do I draw? No, not necessarily case 2. I don't want to get into case 2 just yet. The little rope thing? Sure. How about the little rope thing? When this A slides out on its own, what happens? How about I draw the other part? Right? How about I draw the bottom part? I mean the top part. No. The top part, right? It's this. It's a combined. I'm going to draw it as a combined system. Yes, there's technically a little line between the two because there's 2, right? Okay. But it's a combined system. The top thing weighs 60 pounds, right? The middle book, or whatever this thing is, weighs 40 pounds. Okay. There's a tension T here. Okay. And then here, upward, there is NBC. And because that's, remember, it's pushing down on the bottom, so it's pushing up on the top. And then here's the question: which way do I draw that friction force FB? See, notice friction force FB up here. Up there? And which way do I draw it on this one? You flip it. You flip it. It's got to go the other way. Yeah, it's got to go the other way. So it's going to be like this. Now, by doing all this, and notice T, they gave me this nice little fancy thing. It's a 8, 15, 17 triangle. How fancy is that? Okay. I believe I can write a couple more equations. Watch this. I can write this. Sum of forces in the x direction equals 0. Right being positive. What do we got? Well, you got FB minus 15/17 t equals 0. That's pretty easy, right? And sum of forces in the y direction equals 0, up being positive. What do you got? Well, you got minus 60, minus 40, plus NBC, that's the normal force pushing up on the thing, minus 8/17 t. I'll give you a moment to get that down. Now, by doing the top part, how many more unknowns have I introduced? One more unknown. Notice T. So now my set of unknowns has 6. I have written them in green there. P, FB, FD, ND, NBC, and T. I've introduced one more unknown, the rope. How many more equations have I introduced? 2. So how many equations, how many unknown do I have? 6 equations, 6 unknown. I can solve it. Not easy, not friendly, not fun maybe. I think it's fun. But you might not think it's fun. But you can solve it, right? You can solve 6 equations, 6 unknown. Okay? Now I'm going to help you. I'm going to cut to the chase here. If you go ahead and solve it, you get P equals 63.5 pounds. Okay? That's just for case A, where A slides out on its own. It takes that force. Now, what about the other case where they slide together? You have to analyze that separately. Okay? We'll talk about that at another point.